there are several applications for brain-computer interfaces. You mentioned people that are paralyzed. They can be used for psychiatric and cognitive therapies, for advanced neurological monitoring, etc. Can you explain a bit more how that signal translation is happening? How do you translate signals into something that's useful? One of the more impressive, I guess, to the lay public examples are when people that can't speak can suddenly communicate because those signals can get translated into words. And I'm wondering, how does that happen? How does that happen in different languages? How much do those signals differ? Does that mean that you need to develop a solution in each country to be able to decode those signals? Can you, in a simplified way, explain a little bit more about that?
Yeah, I'll talk about that specific example, Tjasa, because it's very cool. Because right now, when people talk about the applications for BCI, there are many potential applications and some future applications. And sometimes people will sort of lump them all together. But what we do know we can do for currently with BCI, based on science and experiments that have been done in humans as well, is we can decode motor intent, meaning we can have you move a cursor on the screen or reach in space, or we can actually decode what you want to say. And even if, like I said, you can't speak, we can actually decode what your intention to speak is. And I'll explain that really quickly because just as an example. So what the BCI does is just reads out your neural signals. Every time you decide to do something, and sometimes unconsciously you're doing something, your brain has electrical signals that are generated from the neurons. So let's say right now I'm trying to say my name, Stephen. In my brain, I'm generating electrical signals that correlate to that. So the BCI takes those signals and puts it into a computer. The computer is then reading out those brain signals, and using computing power, we're able to correlate what those signals are, what intentions there are. So for instance, if I have myself reaching to the right, I'm just reaching to the right, I can read out brain signals, say, oh, when he reaches to the right, these are what the signals look like. When I reach to the left, oh, the signals look like this. And therefore now the computer knows, looking at the brain signals, these signals means he wants to move to right. These signals means this pattern means he wants to move to left. So similar to that with speech generation as well too, which is much more complex than just reaching around in space. There are certain parts of the brain that are specific for certain activities. Certain parts are for hearing, certain parts are for seeing, certain parts are for speaking, some parts are for moving. The brain isn't a general object, but there's multiple areas that have multiple areas do different things. So the speech area we know we can tap into based on experiments, and then we can have you say things, and then we can correlate what you're trying to say with certain speech patterns, and then we can then put that now, because we have large language models of things, actually create a speech synthesizer that can actually take what you're trying to say and produce that speech. So there's a little bit of training involved with all these systems, Tjasa. None of these are, you plug it in and from day one it works. For every person, it has to be customized slightly, but even the training can be done in a much more efficient manner than used to be before. And you're asking about languages. Yes, the great thing is, you may speak a different language than I do, but our brains are mapped fairly similarly, meaning that where my brain is mapped for English is in the same area your brain is probably mapped for Slovenian, if that was your first language. So by tapping into that and taking advantage of the large language database models, we know what you're trying to say, and one we can train you, like say, yes, I was trying to say, water, and these brain signals came out, then we can actually teach it to basically say, oh, when she's trying to make these signals, when these signals generate, she meant to say water.